So let's first explain a little bit about iSCSI. So just like Fibre Channel, so we consider Fibre Channel a way to transport our data packets or our storage packets across the network. So what does a Fibre Channel frame consist of? Well, of course it has a Fibre Channel header, where I just specify some source addresses and destination addresses in it, maybe some vSAN tagging in there. But what are the contents, the data frame in the Fibre Channel header? What is that? What is that for kind of packet? That packet is a SCSI packet. So either a SCSI read or write. So SCSI is the protocol that a host uses to talk to storage. There are other protocols like SATA or SAS or anything, but SCSI is the de facto standard for communicating between a host and a disk. So a SCSI command, so either a read command or a write command or any other command that I can have, is transported, is encapsulated into a Fibre Channel header. And that SCSI command is then transported from the host towards the disk. That disk will decapsulate the Fibre Channel header and will start looking at the SCSI frame or the SCSI command and then reply as it should. So that is Fibre Channel. Now there are other ways to transport SCSI commands across the network. So we have, this is just native Fibre Channel. Of course we already talked about Fibre Channel over Ethernet. Fibre Channel over Ethernet is used a little bit different because Fibre Channel over Ethernet is just Fibre Channel. So we have our SCSI frame here. We have still that Fibre Channel header, and then in front of that Fibre Channel header we place an Ethernet header. And that Ethernet header is just used as a transport from the first side of the link to the other side of the link. Because on the other side of the link we will decapsulate the packet and start processing the Fibre Channel frame just as we would do in a normal Fibre Channel switch. Well, we talked about this last week. Another option is Fibre Channel over IP. This is not something we use here because this is used as an extension between data centers. So this is to transport Fibre Channel frames. So remember, we have our SCSI command, we have the Fibre Channel frame, and we encapsulate that Fibre Channel frame into a TCP frame. And of course TCP uses IP and Ethernet to be transported. So this is just my original frame here, that Fibre Channel iSCSI piece. Then we use a special TCP port. So this is my FCIP encapsulation. And of course TCP is transported over IP. So this is FCIP, not used for host to disk connectivity. It's just used from switch to switch connectivity and usually between different data centers. This is a topic that we discuss extensively in the data center bootcamps. The last part that we focus on is iSCSI. Oh, let me change colors. iSCSI, it has nothing to do with Fibre Channel. That's for sure. So Fibre Channel is just a way to transport SCSI frames, remember? And with FCOE, we want to transport those frames into something else. So that's just a tunnel mechanism. And we still do Fibre Channel logic and processing as we are used to. iSCSI is another way of transporting SCSI commands without relying on Fibre Channel. So usually when you add storage to, let's say, an ESX server, we use iSCSI, NFS, or Fibre Channel, right? NFS is something completely different. NFS is a file sharing protocol, and that has nothing to do with SCSI commands. So these are not raw disk commands. These are just file sharing commands that an OS is just using to communicate with a disk or with this other server hosting files. So NFS is a file sharing protocol, not used for this. So not talking about NFS. So we could never do boot from NFS because NFS is a file sharing protocol, and file sharing protocols are just OS to OS talking to each other and just exchanging files in different form factors. So I cannot do that injection on the SCSI bus in the system because I cannot send those raw commands. I would need to translate the raw commands to intelligent file sharing commands, And that is just way too much overhead to run on an HBA. So for booting from NFS, we cannot do that. We can do boot from iSCSI because iSCSI still uses that raw SCSI command, and that we encapsulate that totally differently. So imagine that we do not have the availability over a fiber channel fabric. And our storage array is also connected via an IP connection to the network. So if I still want to do remote booting, we will need to use iSCSI. Because iSCSI still uses to transport those raw commands, so my NIC, my network card, can still do the receive the SCSI frames as I would inject another disk in the SCSI bus of the system, the local SCSI bus. And what happens here is this iSCSI encapsulation is done in hardware during the booting. This is called iSCSI offloading. So offloading means I let the processing of the iSCSI header to the network card, to the network interface card. So because we do this in hardware and not in the operating system itself, we can translate the hardware offloading to a raw SCSI command and inject that SCSI command into the local SCSI bus. So therefore we can use iSCSI for booting because we can use those raw commands. What happens when this packet arrives? The host tries to boot from its SCSI bus, sends out a command, the network card receives this packet and then starts encapsulating it. So we first encapsulate that in a certain iSCSI frame. Framing from it just a header with some specific information. Then we attach that to a TCP session or some TCP header, and of course an IP and an Ethernet header. So this is my original data packet, and you see I do not have any fiber channel headers in this packet. I just have a TCP header with some special iSCSI framing. So it's just a TCP session. So what happens when the system boots up? So the server boots. It wants to have a local disk in its SCSI bus, but it will use its network card to do that. The network card will inject that SCSI disk inside the bus. What will it do? This NIC is just configured to an Ethernet switch. So no zoning, no NPV stuff, no floggies, no everything. It's just an Ethernet switch. But if I have my storage array down here, how do I access my storage array? Well, this storage array, will have an IP address. I need to know what IP address that is. Just like I would need to know what WWPN it is. Second, this network card also needs to have an IP address. Because if the host doesn't have an IP address, how can it set up a TCP session? So I need to assign an IP address to the network card during the boot up of the server. So first of all, I establish connectivity. I can do this via DHCP, or I can do static configuration, or I can do a pooled configuration for this. So IP address, first step, establish connectivity. So now I can start exchanging information between these two devices. What else do I need? In Fiber Channel, the WW name, worldwide port name, is used to identify the system. So to identify the server or to identify the disk. In iSCSI, you have kind of the same thing, but then it is called an IQN or symbolic node name. Node name. So you could see these names are used interchangeably, IQN or symbolic node name. And this is a name that is also used to ID the disk or the server. So every device running iSCSI has an IQN. Every disk has an IQN. Every server has an IQN. It's not like WW port names that every port has an IQN in this case. but an IQN is just system-wide, so it's more comparable to a worldwide node name. But you do not use the worldwide node name to access disks, for example. I use a worldwide port name not for direct connectivity. I do use an IQN for connectivity. So in this case, I first need to have IP connectivity. So in my boot policy, because I configured this during a boot policy, I first need to make sure that I have connectivity. So I need to have an IP address. I need to have a MAC address, of course. That's also configured during the configuration of the system, of course. I need to configure for myself, I need to configure an IQN. So the host, the network card needs to have an IQN of its own. And I need to configure the remote IQN. So what disk am I booting from? And where is that? So the remote IP. So what do I specify in my boot policy? I specify the remote IQN and I specify the remote IP of the system. And I do some other things, but we'll come back to that when we start demoing this. So configuring the IQN, configuring the IP address, where is it, what disk am I using? Other things you can do with iSCSI is authentication. I can use username password authentication to access disks in the iSCSI network. So what username and password might I need to use? So it's not required. I can just access it. But some people like to do authentication on iSCSI. So I need to specify authentication parameters. Also something that I need to do in my boot policy. And of course, when configuring the network card, I need to specify that IP information and I need to specify that IQN information. But that's not something I do in the boot policy, that's something I do in the networking configuration. So is this process clear? I need to have IP connectivity, I need to have identifiers for the disks, so I need to have an IQN configured here and there. And then I can start doing then I can set up my TCP session, maybe authenticate the TCP session, and then start establishing connectivity. So when I'm finished, I have the TCP session running and I can start issuing SCSI commands to it. So the first step in authenticating is that the host will send a username password to the disk and the disk will check, is this the right server? Are these my credentials that I expect? And then I can also do that vice versa. So the disk can also authenticate the server back. Right? So this is the first step. So if any server in the network has the username password of the disk, it can access it. But I can also mutually authenticate that. So I can do a reverse authentication saying, I need to make sure that you are exactly who I expect you to be. So mutual authentication, but I don't think the encryption is there. We have a comment, maybe iSCSI over IPsec, that's definitely supported, yes. I can do iSCSI in IPsec tunnels. Some implementations even support that. So the Windows software initiator, so the Microsoft iSCSI initiator also supports some iSCSI things. I never tried it though. But yes, that is a supported configuration. Just like running, in this case, like FCIP, running that over IPsec, that's definitely supported as well. We have our thing, we have discussed iSCSI now. So we know how this iSCSI data communication works. The next part is, how does this work on the MDS? Because like I said, I do not have an iSCSI storage array, but I do have fiber channel disks and I have an MDS capable of doing iSCSI. So what does it mean from the MDS standpoint? As I said before, I just have a host, can be any Windows machine or any Linux machine or ESX host that can set up a TCP session towards a storage array. So just a disk where I can access my data. This is iSCSI data packets. But what I have now is I have that same disk. Let me try a little bit higher. I have that same disk, but this is connected to a fiber channel network. So this disk is talking native fiber channel. Assume that. That is connected, of course, to an MDS. Because that talks fiber channel. But my host here wants to talk iSCSI. So how can I solve that? Well, there are certain models of MDS switches that have IP storage features called, or IPS they're called. So IP storage features. One of the IP storage features is the iSCSI feature. And it will do exactly this. So I may have the same MDS or I may have another MDS. And that MDS has an Ethernet port. So that Ethernet port is connected to maybe an Ethernet switch. Let me draw it because, again, iSCSI is just TCP. So TCP can run over anything, right? I can run it over the Ethernet. So I have an Ethernet switch where my server is connected to. And I have another MDS switch down here that also has an Ethernet connection, an IP connection towards that Ethernet switch. And it has a fiber channel link towards the other MDS. Now, that IP storage related feature means that I can translate iSCSI frames into native fiber channel frames. So I can bridge these together. I can bridge these worlds together through the MDS by just spoofing on the MDS that I am an iSCSI initiate or an iSCSI target. So I just spoof that I am a target. So the MDS advertises itself as saying, hey, I am that disk that you want to boot from. It will get the frames, will decapsulate the iSCSI header, and will start adding a fiber channel header to it. So coming another time, I have my server, I have my MDS switch, and I have the fiber channel disk. So iSCSI traffic here, fiber channel traffic there. So internally in that MDS switch, what I do is I have this big MDS switch. I receive an iSCSI frame coming from the server. So iSCSI frame is received. Then this MDS here will advertise itself as being that disk. So it will have a very small disk here, and that small disk will start replying to the iSCSI packets. So I just virtualize a iSCSI disk. Of course, it's virtualized, so every command sent to this virtualized disk needs to be forwarded to the true fiber channel disk. So behind here, the MDS will decapsulate the iSCSI frame and will send out the commands to the actual fiber channel disk. So the SCSI commands encapsulated in fiber channel and send those to the disk. Now that is one way of the communication, right? I send it from the host all the way to the disk. Going back, what do I need to do? The disk needs to reply with the data. But this is an IP host and not a fiber channel host. So the MDS, besides virtualizing a disk, it will start virtualizing a server in the MDS. It will start creating a mini server that on the one end receives packets from iSCSI, decapsulates that, and then issues this server on this network. It will register itself as being a fiber channel host. That meaning I register with the fiber channel name server. So I register myself as being a fiber channel host to the network. And then I can start doing end-to-end communication on fiber channel, and I can do end-to-end communication on iSCSI with the MDS in between. So these are two very important steps. I can only make sure that this will work on the MDS if I configure both how do I advertise which fiber channel disk as being which iSCSI target, and from a server point of view, how do I advertise the server sending me iSCSI frames onto the fiber channel network? I need to be its bridge. I need to log in for him. I need to do all kinds of things for him. So there are two things that you need to configure here, two very important configuration steps. So I need to do my iSCSI configuration. Remember, what do I advertise from the server? Who do I expect sending it me from? Because I need to configure which servers I expect sending me traffic. So assume here I have what I want to focus on, I have two parts of my configuration. A lot of people forget that because they only focus on the iSCSI part. So I configure my iSCSI. Who do I expect sending me? So which servers do I expect sending me packets? And which disks do I want to advertise them? So that is my first part of the configuration. Then second, I configure the fiber channel part of configuration. So I also have fiber channel configuration. How is this host advertised on the network? So which WWPNs does it get, for example? But the most important step here is zoning. I need to zone the server and the disk, or the initiator and the target, together. So zoning is still in place when doing this. It's not that it has automatically access to it. So I need to tell the zone, for example, this virtual WWPN that I allocate has access to the WWPN of the disk. And vice versa for my iSCSI configuration, this IQN can access this IQN. This initiator and this target IQN, these two can match. So zoning is very important. And here comes that proxy question into play. So of course this is already a proxy, right? I translate certain packets towards another network, a totally different network. But this can more be considered iSCSI routing. I route SCSI packets. So SCSI routing. I have one carrier and another carrier, and I route packets in between and I encapsulate them differently. So I encapsulate those into fiber channel frames, but I can also do what's called a proxy initiator feature. What will this do? With a proxy initiator feature enabled, the MDS will not log in every server in here. So if I have multiple servers here, I will have multiple servers here by default, so all having their separate WWPNs and stuff. When I enable proxy initiator, it will get virtualized as a single server. It's like for the target disk, so for the fiber channel disk, it will be like a server, that there is just a single server connecting to various different disks. That is the proxy mode. But we're not going to discuss that in depth today, so just here assume every server logs into the fiber channel fabric. A iSCSI host on the fiber channel network will get a WWPN assigned. It will log into the fiber channel network. The same will happen with the disk. So every disk that I want to advertise on my network will first of all get an IQN. And of course this port, this Ethernet port, will need to have an IP address assigned. So the IP address is only assigned to the switch port on the MDS, so the IP port on the MDS, but every disk that I advertise will have a separate IQN configured, and I need to configure them. And then behind here we just have WWPN to WWPN communication. There are some steps in between, but I'll talk about that on Monday. So there are my IP addresses. So I want to start configuring this. So I want to start configuring my MDS as a iSCSI server because I really need this before I can start configuring my UCS. So I wanted to show you how I configure this. So we log into one of our MDS switches, and we can do all kinds of different features here. So we can do virtualization features, or we can do redundancy features here between different MDS switches. Maybe a VPN will be beneficial here. There we go. So we are on an MDS switch. So I assume that this switch is not very empty, but that's okay. Let me just delete this, no vSAN 10. The no vSAN command is very easy command to clear configuration. So FC13 and 14 are currently working. Can't see it. Let me just shut it. All right, we're pretty much clear. So let's check our Floggy database. We do not have any Floggy right now. So I have disks on FC1, 5, and 6. So I'll say switch port mode is fabric loop because these are looped ports. And I want them to be in vSAN database, in vSAN 500. Create the vSAN, place the ports into the vSAN. And now we should see some disks logging in. There we go. So I configured vSAN 500 and I assigned two interfaces where I have my disk arrays in, and now I see a whole bunch of disks. Everything is logged in correctly. If you check the name server database, all good to go. So I will just configure one fabric right now. I want to configure redundancy. I will not do that right now. I will just configure one MDS to do the translation. So again, I do not need to have this on the same MDS, right? This could be somewhere else in the fiber channel network with all kinds of other switches behind it. In this case, I just do the translation here on this MDS going towards a disk. But this disk does not need to be connected directly to the MDS. It can be anywhere else. But assume that currently it's directly connected, but assume I just use WWPN. So the WWPN, as long as I have access to it, I'm good to go and I can use it. By the way, this feature, this is slow. I don't know anybody who uses this in production. This is a slow feature. The performance of the MDS, that's the bottleneck. The performance of the MDS is very low to do that translation. So this is only used for very specific situations. Actually, iSCSI boot would be beneficial, but if I have an MDS, I would probably just be able to configure fiber channel boot, which is much easier and will allow me to do some more things as well. So iSCSI feature on the MDS, it's a cool feature and it is part of our blueprint for the lab. So we need to know how this works because this is how they will ask you to configure iSCSI boot on the UCS servers in the lab. They will use this feature for that. Technically, they do not need to, but this is very interesting to do in the CCI lab, of course, because this requires expert configuration. But okay, let's move on. So I have fiber channel disks. I might have some zoning in place already. So let me just show zone set active, should be gone. No zoning. So let's just make zone name zone 1 for vSAN 500. I say I place two disks together, so I just want to have an active zoning database just to show you what happens. So I just zone two different disks together, all good to go. So zone set name is zone set 1 for vSAN 500. I say member is zone member, just Z1. Zone set activate CS1 for vSAN 500. Oh, name. I always forget the name. So I have an active zoning database. Assume this is a huge database with all kinds of zoning. So we just have a zone active in our configuration. So now I want to enable iSCSI. What do I need to enable first? I first need to make sure that I have an IP interface. So when we check our show interface brief here, I see 18 fiber channel interfaces, but I also see 4 gigabit Ethernet interfaces. So in this case, I have an MDS called the 2922i, which is exactly the switch that you will see in the lab as well. So the 2922i. And that 2922i has the availability of 4 gigabit Ethernet interfaces. Now, a very important difference here. These are not switch ports. These are IP ports. What this means is they do not run fiber channel switching or Ethernet switching. So if I have my MDS, I have these 4 ports where I can plug in an Ethernet SFP, either copper or fiber, doesn't matter. But these ports do not allow data processing to each other. So these are not transit ports. I can never switch or route packets between 2 gigabit Ethernet interfaces. What these are just host ports like on a server. Of course, from a fiber channel standpoint, the MDS is a switch, but these IP ports are just server ports here. So they just have an IP configured, maybe with a VLAN tag. So I can do sub-interfaces to do VLAN tagging, but I cannot create VLANs on a switch. I just configure an IP address on these interfaces so I can access the network. No switch ports, no VLANs, but I do support sub-interfaces to do VLAN tagging and have multiple IP addresses on the same interface. But that's not a VLAN. I do not call that VLANs. I just call that tagging of packets, segmenting packets, and slicing up my network. That's how I usually call that. So these are host ports or server ports. No transit ports, no switching, no routing. So gigabit Ethernet 1/1. This is, if I configure an IP address here, this is going to be untagged. I'm just going to send untagged traffic. So I'm just going to say this is IP address 10.0.0.1, or let's just something else, 198.18.100.0 or .1.10 with a /24 mask. So this is always interesting. The IP features on the MDS are not very stable. So it says now that it cannot access the IP address because the interface doesn't exist. Well, it does exist. The problem is I need to initialize the IP stack before I start configuring things. Sometimes it works, sometimes it doesn't. So how to initialize the IP stack? Well, just enable one of the features. So in this case, we're going to use iSCSI. This is, by the way, an unlicensed feature. So I can just enable iSCSI without any additional licensing. And if I configure the IP address now it works. So if you get the warning message that it cannot configure your IP, enable one of the IP features. iSCSI, FCIP, anything else, just enable it. Then your IP stack is initialized, and then we can start doing things. So I configured the 198.100.10. Let me use a little scrap paper here to keep track of what I'm doing. So MDS IP is the 198.18.100.10 in the subnet of 198.18.100.0/24. Now I could use routing between this, but in this case I will give the server blades an IP address in this same subnet so they can just talk to each other. I will not be bothered by routing right now. I just want to make sure that the MDS and the server can talk to each other. And I will use the IP addresses from the same subnet range. So that's why I keep track of this. I enabled gig 1.1 on MDS 1. And that port goes to switch 2 interface. Let me look that up where that goes. So gig 1.1 on MDS 1 goes to switch 2 Ethernet 1/11. Now this is a 1 gigabit per second port. It's not a 10 gig port, it's not a fiber channel port, it's just a 1 gig Ethernet port. I'm connecting this to a 10 gig port, so I need to set the rate back to 1 gig. So the connection between here is just a UTP cable with two GLCTs on each end. So the GLCT is the copper SFP from Cisco. And I need to assign a VLAN. Well, let's use VLAN 100 for this. I will do it untagged on the switch, and we'll see how we work with tagging on the server and on the fabric interconnect. We'll see that later. But in this case, towards E111, this is going to send untagged. So switch to Ethernet 111 is going to be an untagged port. So let's configure that. I should have access to this. So my switch 3 is gone right now. Let me check that. So we have a wrong default gateway set on that switch. So that looks better. Ping. Right. So here we go again. There we go. So we're on switch 2 now, and on switch 2, I use not the management interface, but Ethernet 1/11. Let me undo this. Right. Ethernet 1/11 is just a clear interface, no things configured. Like I said, I'm going to configure VLAN 100. This name will be iSCSI. This will be my iSCSI VLAN. Oh. I have some VLAN configured already. This is going to be just a name. I do not need to assign a certain role to the VLAN. It's just a name for this specific VLAN. Ethernet 1/11 is first of all a 1 gig port. So I'm going to set the speed to 1000 instead of 10,000. By default, all the ports on the Nexus are set to 10 gig. In my case, I need to set that back to 1 gig. This is going to be a switch port mode access because it's going to be an untagged port. And the VLAN that I'm going to place this in is VLAN 100. Now, because this is a host port, I can set spam-free port type edge. I do not need to set this as an edge trunk port, just an edge port is enough, because I do not use VLAN tags. So let's check the configuration. It's in VLAN 100, it's an edge port, and the speed is set to 1000. Now it is unconnected right now, so the speed is set okay. That is good. And I see it's automatically exchanging the link speed. So let's go back to our MDS, go into gig 11, which is where I configure it. I need to set up a new session. Gig 1/1, and I should no shut the port, because by default it will be shut down. Now, this will stay down for a minute. because IP interfaces on the MDS, sometimes they act a little bit strange. But at some point, it will start coming online. So it might be that the port is already up here. No, it's also still down here. Or maybe I have a miscabling. Now both still down. This one is still down. This is always difficult to get up. For some reason, ports don't really like being connected to MDSs. This side is now up, so Ethernet 1/11 is up. And this side as well. So it takes a while. Be patient with this. And sometimes if it doesn't work, try setting the speeds to fixed. For example, if auto duplex doesn't work correctly, or no shut them a couple times, but be patient with this. If it is stating to be initializing, let it roll for a number of minutes. So just have it be initializing. But now we are up and running. So if I do a show CDP neighbors, I see that I'm connected to switch 2 on Ethernet 1/11. So that's exactly how I expected it. And I'm running in VLAN 100. Now I can test some things, so I could do on my Nexus 5K, I could start a VLAN interface VLAN 100. Let me just stick that on there, so I always have a host that I can use to ping things from. So I configured a VLAN interface on the Nexus 5K with IP address .1, and as you can see, I am able to ping the .10, which is my MDS. So from the Nexus 5K towards the MDS, I'm operational. Let's make a little drawing about this. So I have my MDS here, and I have my switch 2. So this is MDS 1 and switch 2. This is connected on port 1/1, and this is port 1/11. Connected here on ports FC15. Let me use a different color for that. So on port FC1/5, I have a disk, or I have a number of disks, and I also have some disks on 1/6. Or a Mac Pro on 1/6, whatever you want to see in it. So I'm running this on gig 1/1 connected to 1/11. This port is configured for access VLAN 100. And what I did for additional testing is on this switch 2, I configured VLAN interface 100, where I configured the .1 IP address. So here on my MDS, I have the .10 configured, and on the Nexus, I have the .1 configured, so I can do some pinging. So when we start connecting our servers, we can do some extra pinging there, just to make sure that everything's working, because I need to have an IP connection first. So we have IP connectivity, our VLANs are created, so that is all good. So we can now start doing our iSCSI configuration. I already enabled the feature. I can do it again just to show you. First, I need to enable the feature. Then what is very important, and what a lot of people forget, is to enable the iSCSI feature on the IP port. I need to enable iSCSI on the module. Enable on module. This is from the point where we have a lot of line card slots in modular MDS chassis. In this case, these are just fixed interfaces on a smaller switch. But if I want to reserve resources for certain iSCSI features on certain blades, I need to enable those modules. And that is still a configuration that I need to do. So in this case, my port is 1/1. So I don't even think that I need to enable iSCSI on module 1. Otherwise, I cannot enable anything. What happens now is I get, per physical interface, I get an iSCSI interface. If I did not enable that module, iSCSI enable module, those interfaces will not show up. And I need these interfaces to do my decapsulation. So this is the place, this is where the IP traffic is received, and this is the place where the iSCSI frames are dismantled, or processed, as you can call it. This interface is down. And as I said, I have these 4 interfaces, so these map one-to-one on iSCSI interfaces. So gig 1/1 will be iSCSI 1/1. If this would be gig 2/1, the iSCSI interface will be 2/1. One-to-one mapping. Now, if I have sub-interfaces on gig 1/1, so if I say I want to have hosts in VLAN 100, 200, and 300, I need to configure 3 IP addresses on this interface. Those 3 IP addresses go on different sub-interfaces. I do not get an iSCSI sub-interface. So my iSCSI interface will stay a main interface. As long as it's enabled on the main interface, I can process iSCSI packets on the main interface at every sub-interface that I connect behind it. So iSCSI interface, what do I need to do? First of all, I need to no-shut it. There are some settings that I can do on an iSCSI interface. So if I check my show interface brief now, this does not rely on link status. This is just a no-shut means the link will be up. And it is running in iSCSI mode. That's wow, right? Now I can set some settings here. So first of all, I can set the TCP and IP settings of this interface. So I configure the IP address on the physical interface itself, and I configure TCP parameters on the iSCSI interface. For example, which TCP port will I start listening on to accept iSCSI packets? That's a very important port. Do I want to set certain QoS settings on the traffic? And are there some TCP related features that I want to enable, like path empty discovery and all kinds of other things? Do I want to set traffic shaping for this interface? I can shape the iSCSI traffic per interface, not per host or per thing, per interface. So these are limited in terms of flexibility, but you can use it. But port is, of course, maybe the most used port. By default, iSCSI will listen on TCP port, show interface, iSCSI 1/1, will listen on TCP port 3260. So here we have the local port, so the default listening port is 3260 on TCP. So this port, along with that IP address 10, I enabled that iSCSI interface, and now I'm listening on TCP 3260. Important to remember, because this port is going to be my destination port seen from the server, right? If I set up connections from the server towards another one, I set that up towards the listener port, which is 3260 in this case, which I can change if I wanted to. So it is running on 1 gig and it is not carrying any TCP connections. So I am running iSCSI now. I accept iSCSI packets, but I'm not doing anything else. I am accepting iSCSI packets, I'm looking at them, but there's no other configuration apart from enabling some interfaces. So what do I need to do? I need to do is what we talked about. I need to configure an initiator, so which server is going to log into the network, so which server will try to access me. And what I mean with which server is either which IQN or which IP address it is coming in from. I can choose whether I want to specify the IP or want to specify IQN. So I can choose either one, and I can mix this. So I can configure one server based on its IQN and the other server based on its IP. And so that is my first configuration. So, and then how do I identify the server, so ID the server, and then present the server on Fibre Channel. So which WWPN does it get? Which vSAN is it going to be in? And all kinds of other things. So I need to identify the server and I need to configure its representation on the fiber channel side of the switch. So that's the initiator, the server, the blade. Then I have my target. Same thing. I need to ID the disk. Meaning, which worldwide port name do I want to use? In which vSAN, for example. Actually, not the vSAN, it will figure out what vSAN it will be. So which worldwide port name am I going to use? And then I need to present this to the iSCSI network. So which IQN will it have? On which interface will it be presented? So which interface will offer this disk towards the rest of the network? So that's where it will learn about which IQN it will use locally. So I do not configure an IQN on a disk, or which IP it will use locally. So I do not configure a separate IP address for each disk. I use one IP address on the interface, and based on the interface that I allow that specific target disk on, it's going to find out which IP address to use. So all these things come together. So I need to identify an initiator and a target, and I need to present an initiator and a target to the other sides of the network. So let's first do that. Let's start with the initiator. Now I do not know the initiator yet because I did not configure my server yet, but I will assume some IQN naming that I will start using. So I need to know what the IQN or the IP address of the server is. I'm not very clear about which IP I'm going to use because that's probably going to be a pooled one, but I can specify the IQN. So let's do that. So we enabled iSCSI, and now what I do is I say I'm going to configure an iSCSI initiator. And here I see that I can specify either the IP address or the name. I'm going to specify the name. IQNs are in a certain standard format. They always start with IQN dot. Then behind this, it doesn't really matter anymore. But it needs to be at least 16 characters. Or 16 bytes, sorry, but that is 16 characters in ASCII. So at least 16 characters. What you usually see is the date of when this server was configured, for example, or when this server was started, or when the IQN name was reserved or anything. So let's just use the date of today, so 2013, 11/30. Then we're going to say another dot. And then we're going to say this will be blade 1. Now that should be long enough. That is long enough. So we have this. So I need to make sure now that my UCS will start allocating this IQN to its iSCSI boot driver. Remember, we need to specify in the iSCSI boot driver which IP address do we have, which IQN do we have, and which things do we want to access. So this is now going to be the IQN pool that I will start configuring later. So let's remember that here in my scrap paper sheet. IQN pool is this. So it will start with blade 1 and then go to 2, 3, 4, 5, 6, for example. So 2, 3, 4, 5, 6. Those will be my IQN pools. And this needs to match, of course, because this is how the MDS will start identifying the server. All right. What else do I specify here? A number of options. How do I authenticate? Well, I'm not going to authenticate right now because that will start pushing a little bit on the time. But I can assign vSAN membership for the initiator. So in which vSAN do I want to access storage? I can assign multiple vSANs here. So first of all, I need to specify this vSAN of 500, sorry. This initiator needs to access disks that are hosted in vSAN 500. If I want to access multiple vSANs, I would just keep on configuring vSAN commands here. So vSAN 10, vSAN 20, vSAN 30, and then the initiator will start get assigned on each vSAN. Now, second thing that it needs, so vSAN membership, as specified here. I need to specify, I specified the IQN of the server, I specified the vSAN. Now I need to specify which WWPN does this initiator get on the network. That's going to be static. So by default, it will dynamically allocate a certain worldwide name. That's not very beneficial, because then if I do it dynamically, I cannot use that WWPN in zoning, because every time the iSCSI host will log in, it will get a different worldwide port name. So I will probably want to configure this statically. And then I still do not need to configure it manually. I can just ask the system for, hey, take some of your reserved range that you have for this, take some of that range and use that here. So kind of a pooled approach, just like in the UCS. So I can say statically assign a PWWN. I can say how much PWWNs it needs to generate, meaning I can configure multiple PWWNs. I use multiple PWWNs if I use storage in multiple vSANs. So in every vSAN I will use a different port worldwide name. So I never have overlapping port worldwide names, not even between different vSANs. I could have the same WWPN living in one vSAN and the same WWN in the other vSAN, but it's a best practice to keep that separate. In my case, I only have one vSAN, so I'm just going to allow one static port worldwide name. Same for the node worldwide name, statically assign that. What do I have now? Show run iSCSI, sorry, section iSCSI. I see that I enabled the feature, and I see that I configured an IQN. So I expect to see this a server accessing me through this that identifies itself with this IQN. And now I say, all right, you can access storage in this vSAN and use these worldwide names to do that. And I no shut up my iSCSI interface, very important. So that's my first step. So we said identify the server, and we said how do I represent you on the network. All good to go. Next step, the target. I say iSCSI virtual target, because this is not a physical target, it's a virtual target. It is a real server, but a virtual target. And here I configure the IQN that I am going to give to this target. So remember here, I need to identify it based on its WWPN, but I need to present the disk with a certain IQN to the network. So that's what I specify here. What is the name of the disk? This will be IQN.2013-1130 boot disk 1, for example. That's going to be my target. So in the UCS, the server will boot towards this IQN. So let me take that. So the target disk is IQN that with IP address 198.18.100.10. Remember, that is the IP address of the MDS stated here. So my IQN pool on the server will be this, and I will specify this to boot from. That will be my target disk with this IQN. Now, same kind of options here. I need to assign, all right, how do you identify this guy? Which PWWN do I specify going to this server? So which disk am I going to use for my configurations? That will be my first disk. That is this guy, 214C. So I will say, all right, PWWN, this. Which LUN can I access from this guy? So I can specify, if I do not specify the LUN ID, then I will access every volume that this disk has. If the disk has multiple volumes, I would be able to access all of them. If I want to limit that for some reason, so access control, which FC LUN do I advertise in this IQN? In this case, I don't really care because I only have LUN 0. Well, let's configure that. This is a place where I can do LUN masking, as they call this. So I can, besides translating iSCSI frames into fiber channel frames, I can even rewrite some parts of the packet, saying on the fiber channel network, this is LAN 0, but on the iSCSI network, I want the server to access LAN 1, or vice versa. On the fiber channel disk, it is LAN 5, but the server thinks it is connecting to LAN 0. So I can do LAN masking. So these numbers do not need to match. That is some benefit of this feature. And I can even make this high available. So the MDS will not provide you with synchronization of the disks, but if I have some sort of storage array that will do replication between two disks, so a RAID setup, that RAID setup I can specify the two PWWNs of the disks here in this configuration, and then the MDS will arrange the failover. That's not used a lot because usually the iSCSI or the PWWN advertised is already a RAID array, is already a RAID configured storage device. So in this case, I don't really care about that. So then I'm done. I specify a certain WWN, I specify which LANs can I access on it, in this case just LAN 0, and I provide it on LAN 0. Then by default, every iSCSI interface in the system will advertise this target. This can be good, but I can advertise it on a certain interface. In my case, it's gig 1/1. So this is not mapping to iSCSI interfaces, this is mapping to physical Ethernet interfaces. And this is also where I can be as specific as a sub-interface. So like I said, I cannot shut and no shut separate iSCSI interfaces if I'm running in sub-interfaces. If I run gigabit Ethernet sub-interfaces, I cannot specify that during my iSCSI interface mappings, but I can do that here. On which interface do I advertise this specific target? So in my case, it's going to be gig 1/1, but I can set the sub-interface behind here. In my case, okay. And then the final step, so by default, nobody is allowed to access it. So I need to specify which initiator or initiators can access this target. So if I want to have everybody to access it, I would specify all initiator permit. And then secondly, I can be more specific and just specify which initiator, either IP or IQN name, do I want to give access to this disk. In my case, I'm going to give only Blade 1 access. That's only the only IQN I configured. So I copy this. I say, this IQN is permitted. Done. So that is iSCSI access control. This doesn't say anything about the fiber channel zoning that I also need to do. So I still need to do fiber channel zoning as well. And I have so I have fiber channel access control and I have iSCSI access control. And this is iSCSI access control. Which interface do I advertise? Which iSCSI initiator can access this target? And then second, I also need to do zoning. So back to our target configuration. That's actually everything that I can configure. So iSCSI access control, which initiator and which interface do I specify, do I advertise it on, and to which physical disk do I map it on the back end. So I specified how do I recognize my real iSCSI initiator, so the actual server, that is going to be my UCS blade. How do I advertise that on the fiber channel network behind it? And then in which vSAN do I give that initiator access to? And then the second step, I identify which port worldwide name in the fiber channel network do I want to use? And how do I advertise that specific PWWN towards the iSCSI network? And for some reason it doesn't show the other configuration here, but yeah, here do you see it. So it didn't show you all configuration. So I also specified iSCSI access control. So this is how do I permit and deny things in the iSCSI network? That's what I do under the virtual target configuration. But now my last step in this MDS configuration is the fiber channel access control. So I need to specify zoning for this. I already have an active zone set in vSAN 500, which is zone set ZS1. And now I need to specify an additional zone for this. So this is going to be, let's call this iSCSI zone 1. Now, I can do zoning for iSCSI on 3 different ways. Fortunately, right? Not enough options. I can say map it to a certain port worldwide name. This port worldwide name will be that system assigned port worldwide name, like this one. If I specify this port worldwide name and that port, so the virtual port worldwide name and the physical port worldwide name together, they can access each other. But the MDS also supports iSCSI zoning, meaning adding the IP address of the host or adding the IQN of the host to this zone. And it will automatically detect which PWWN is behind it and will start issuing the correct name server entries for that. So in my case, I want to do both. Actually, I'm going to build 2 of the same zones. So first I'm going to zone it together based on the PWWN. So the system assigned static PWWN. And that accesses disk, this one, in my iSCSI virtual target configuration. Done. Exit out. Now I'm going to create a second zone, zone 2. And here I'm going to say, all right, match this iSCSI IQN, so just the clear text field, which is my, this one, IQN blade 1. So these are not the virtual host, these are just physical initiator and physical port worldwide name of the disk behind it. Zone these 2 together. And once we start seeing the blade logging into the MDS, you will start seeing that these 2 will be exactly the same. We'll carry the exact same FCID. The FCID is comparable to the IP address in the IP world, so it's just that logical address. I will see the same FCID here, and I see the same FCID here at the IQN part. And that will be more clear when we start seeing it being activated. So I activate the zoning right now. That is active. So I have 2 iSCSI zones, and currently the start entries show first of all the FCID that the system is using. So the physical disk is already logged into the network. That's okay, that's what I expected. And the iSCSI server, both its system assigned PWWN is not logged in yet, and the IQN itself is not logged in yet. Both expected.